So I would like to invite our next speaker. Dr. Bao-Son Trinh is a visiting professor at Northern Illinois University, supported by the Fulbright Scholar in Resident Program. In this role, Dr. Trinh assists Professor Melissa Lenczewski in teaching undergraduate courses in the Department of Earth, Atmosphere, and Environment. He also collaborates with colleagues from the U.S. Geological Survey on research projects investigating PFAS and microplastic in groundwater samples from McHenry County. Dr. Trinh has over a decade of teaching experience in Vietnam National University, Ho Chi Minh City. His current research focuses on microplastic, water quality, and ecotoxicology. So please welcome me in joining Dr. Trinh.
Good morning. Good morning, everybody. So today I would like to share with you the preliminary assessment of microplastics and PFAS occurrence in McHenry County groundwater using laser direct infrared chemical image (LDIR). So at first, I would like to talk about the McHenry County groundwater monitoring network. So McHenry County has concern regarding their groundwater resources due to rapid population growth, and groundwater is their sole source of drinking water. Purpose of network to acquire the background data set for groundwater monitoring and modeling effort for resource conservation, environmental protection, and land development planning. About the PFAS and polymer sampling. So PFAS and polymer sample are selected well in McHenry groundwater monitoring network were collected in 2020. There are about more than 13 monitoring wells were collected. PFAS analyzed in 2020. And microplastics were analyzed in 2025 and 2026. So there are 34 PFAS were tested in each sample. So PFAS were analyzed with the direct aqueous injection liquid chromatography tandem mass spectrometry. And here is some the total PFAS in all the wells. So it varies from 20 to about 100 micrograms per liter. So about the microplastic sample and analysis, at the same time we have collect 250 milliliter water sample for microplastic analysis, and they were stored at minus 20 degrees Celsius until fall 2025. The sample were filtered through the polyester gold coated filter, and then rinsed with zinc chloride to separate microplastics from heavy material, and floated portion were finally filtered with the gold filter. So all the filter samples were analyzed by the LDIR. So the initial polymer result, we found that there are more than 50% total polymer particles are rubbers. The mean total polymer particle in groundwater sample vary from about 105,000 to 13,000 microparticles per liter. So if we take out rubber, and then we have about 14 types of microplastics were identified. So in there we have about 30% of polyamides, about 11 to 13% of polyurethane, PET, PTFEs. These are very popular household plastic material. So particularly some microplastics were found in some very deep wells. For example, one well up to 200 feet, and we can find about 9,500 microplastics per litre were identified. About the size distribution of the microplastics, so mostly smaller than 300 micrometer, and about more than from 80 to 90% smaller than 50 micrometer. So this could be because the smaller size can be better go into the aquifer. So in very general and very initial result, we found out the correlation between the PFAS and polymer. So in the total polymer, we found out that the better correlation than in particular with rubber or microplastics. The correlation between PFAS and microplastics, we have the R square about 0.64 indicated that microplastics can be absorbed by PFAS compounds. And this is consistent with some previous publication. I have some general conclusion. That's polymers, including rubber and microplastics, were found in groundwater sample from shallow to deep wells. And rubber is rather common, could be come from tire sources. Preliminary seem to be correlation with PFAS, and the research is still underway. So we thank you for the support from the USGS for providing groundwater sample, PFAS analysis, and discussion about microplastics. So our labs. Yeah, and thank you for listening.
Is there any question?
Thank you. My question is in regards to the timing of your sampling. When you say you made a correlation between the PFAS and the microplastics, but you sampled your PFAS in 2020 and your microplastics in 2025, 26, what is, I guess my question is, how can you make that correlation with such a large time difference in between your sampling?
So let me answer your question because I'm one of the participants in his project. So we did sampling in 2020, both for the PFAS and the microplastic. Yeah.
Thank you. I just find it like really interesting and that you're seeing a lot of them, thousands. So I'm not familiar with the area, but what is the geology? What is the aquifer type? Do you have a strong connection with the surface, or these aquifers are, semi-confined? I'm just curious to why you're seeing so many.
We have just go in detail analyze about the connection between the aquifer and surface water. But according as far I learned that there's some connection between with the shallow wells. So because in some agriculture area we found likely more microplastic in the urban area.
I have a question from online. Rachel Golda asks, do you know if groundwater recharge or injection occurs within the test site?
Groundwater recharge? Sorry, we don't have that information, sorry.
Can you say that again? Sorry. Okay.
We don't have that information.
Okay, great, thank you.
Would you be so kind as go back to your polymer distributions from earlier? I'm going to pick on polymer distributions today. Keep going. Keep going. Right there. I see that for one site. Do you see it says polyolefin?
Yep.
But then also you have listed polypropylene and polyethylene. So what's the difference between those polymers and polyolefins? Are they not all polyolefins? I'm just a bit confused of how you made these distinctions on polymer types.
Yeah, the one side, the polyolefin is too high, but right, because this is the main result. So there one side very high polyolefin. Yeah, but the analyze the results show us we don't found so much the percentage of polyolefin in this sample. I don't know why.
Yeah, these are like preliminary data that we have done so far, but we are hoping in the coming year we will do this data water sample collection, and that we will compare like 2020 data, and then that maybe 2026 or 27 if we do like another sampling round, and then we could compare, and then we can deep dive in the data why we found a lot of polyolefin in this area. So yeah, thank you.
One more question from Zoom. Sarah Nedrick asked, which PFAS compounds were detected in groundwater? How do you know they were bound to microplastic particles?
So in this research, actually, we get the data, PFAS data from our collaborator from the USGS, and then from our side, we did these microplastic polymer, and then we just trying to correlate with the PFAS and then these microplastic concentration. Is there any correlation between these microplastic and PFAS compound?
More than a question is just, I know this is preliminary, so something to consider. I think there's a typo where it says conducted by Microplastics. I think it's missing something there.
You mean in this slide?
Yeah, but and then the map, conducted by, and then I think there's just a typo there, which is, I do it all the time. That's why
thank you. Yeah, thank you. We didn't see that. Thank you so much. Any questions? Once, twice? Okay.
So this is more of a geology question, but are there any sediment cores around the area that you could look at to determine, I guess, penetration of the plastics into the aquifers?
Okay. So, yeah.
It's all right. Yes, so this is part of a long-term study with the McHenry County. So all of these wells, you can go on to, the water well samples and read all the geology of all of them. So we do have so this is just a small portion of this project. So yeah, we can look at recharge into there. The sample that's got the middle and the largest microplastic analysis inside of there, it is actually located right next to a landfill. And they do know that there is the sediments and the transport into there. Part of the problem is, so this is a long-term project with McHenry, to say it. So in 2020, when they decided to add in the PFAS data into this to look at it, they're like, why are we finding all of this? Well, when they were sampling it, and go to your question, what they asked, we did not have a way of analyzing for microplastics. We were talking about it, and so they said, well, we'll just take a bottle, and we stored them for a long time, and then we've just started getting into this. So this is really preliminary. We just finished some of these analysis, I think, like last week. So we're really just starting to understand the geology, the recharge into the system, and trying to get at some of these really important questions into there. to be able to really get at like the aquifer recharge and some of the cores in there. What we're planning on doing is going back to those sampling sites and resampling, because especially if you go back to the PFAS analysis, slide on there where it says the amount of PFAS in there, McHenry really wants us to, or McHenry would like to have them resample to see if that's really the case. And asking about, so this is just some of our ideas about why we're seeing a correlation. To me, it's really surprising about how much plastic we're finding in groundwater, especially something that is 200 feet or even deeper down. So that's part of, well, why are we finding so much plastic and PFAS in these samples? So that, and if you go back a couple slides to the USGS one, if you go down to the bottom left corner down there, you can read all of this stuff on the PFAS. So it's got the geology in there, it's got a lot of the information on there. We were just adding in the microplastic into there. So thank you.